Hello everyone, welcome to ExamRat. My name is Shatabdi, I'm a second year medical student. So today we're going to be discussing about the sums of the chapter motion. So keeping in mind all the formulas that we learned, all the distance graph, all the distance time graph, velocity time graph that we have so far covered, we are going to answer some of these questions. So the first question says that a farmer moves along the boundary of a square field of side 10 meter in 40 seconds. What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds from his initial position? Okay. So at first it says that the farmer moves along the entire boundary of the square field in 40 seconds. Each side is 10 meter. So we get the perimeter as 40 meter. Okay. So he is moving. He moved this whole boundary in 40 seconds, right? So to move 40 meter, he took 40 seconds. Therefore, to move 1 meter, he will take obviously 1 second, right? So first we have to convert this 2 minute 20 second into 120 plus 20 second, right? Which comes to 140. Okay. So basically we know that every second he is moving a distance of 1 meter. So in obviously 140 seconds he would have moved 140 meters. So now we have to basically calculate. So let him start from this point. Okay. So when he covers the field once, he's covering 40. Then he again goes around the field and he's covering again 80. Right? Okay. Now he's again back to his main position. Now he's again moving. So he's again covered another 40 meters. So there he's taken 3 rounds up till now. And then he has just gone 20 meter more. Right? So we get the sum of 140 here. And where is he now then? He has just moved 20 after the initial position. So now he is here. So what will be the displacement? It is nothing but the diagonal of the square. So we calculate of the diagonal of the square field. So displacement of the man from initial position is root over 10 square plus 10 square. Right? We calculated by the Pythagoras theorem. So root 200, which is 10 root 2 meter. So displacement from its initial position is 10 root 2 meter. So I hope it is clear that how we are calculating it. It is nothing but we are just calculating how much he covers in every round and its difference between its final and initial points. Okay. What can you say about the motion of an object whose distance time graph is a straight line parallel to the time axis? So first let's draw the distance time graph. We know that distance is on the y-axis and time is on the x-axis. So here they are saying that the distance time graph is a straight line parallel to the time axis. So here, so let this point be say 20 and this is 0, 20, whatever. So what does the straight line indicate? When we talked about the graphs in our previous class, in case you've missed it, you can go to our YouTube channel and check it. So when we talked about it, we knew that when it is saying that the position from its initial position of the object or of the vehicle has been constant for a particular period of time, or as and when time is passing by, you are seeing that the initial position, that the difference between the initial and the final position of the vehicle has remained the same. It is 20 it is 20 meter every second, right, as time passes by. That means what? This means basically that the object is not moving because it is at the same point for a long time. So the object is at rest, right? But this is only in the case of a distance time graph. If I had told you that it is a velocity time graph, then the whole thing would have changed, because now it is showing constant velocity. It does not mean that the body is stationary, right? It is meaning that it has the same velocity with every period of time, which means the body is moving with uniform speed. Okay, and again, if I talk about an acceleration time graph, let's say for example, and again I give a straight line parallel to the time axis. So here what is going to happen? We know that it will move with a steady acceleration, right? A body is moving with steady acceleration. So this is the difference. A bus starts from rest, moves with a uniform acceleration of 0.1 meter per second for 2 minutes. Find the speed acquired and the distance traveled. Okay. So uniform acceleration for 2 minutes. Let's first write what data we have. So acceleration is per second square, time is 2 minutes. Starts from rest means initial velocity is 0, right? And find the speed acquired. V we have to find, we don't have it right now, so we use the first law of motion, first equation of motion, sorry, and we get it as 0.2 meter per second. Okay. This is the speed acquired, A. Now we come to B. So now we have also found out, right? So how will we find out the distance traveled? We can find out by S equals to V square minus U square by 2A, or S equals to V square by 2A because U square is 0. So just write it with a different. S equals to, what is V square? 0.2 into 0.2 by 2 into 0.1. It is 0.2 meter. Okay. So this was a simple application of formulas. A stone is thrown in a vertically upward direction with a velocity of 5 meter per second. If the acceleration of the stone during its motion is 10 meter per second square in the downward direction, what will be the height attained by the stone and how much time will it take to reach there? Okay, so the stone is thrown vertically upwards, right? And you are saying acceleration is, here acceleration means nothing but acceleration due to gravity, and it is in the downward direction, so it will be minus 10 meter per second square because we are taking this displacement as the positive displacement, right? So this one will be downwards, will be negative. Okay. So we have the acceleration here, minus 10 meter per second. We have the velocity here, which is 5 meter per second. Okay, so when the stone reaches its highest point, momentarily it comes to rest. So we have this initial velocity as 5 meter per second, and we have its final velocity as 0 meter per second because it is momentarily at rest when it reaches the highest point. So we have got all these datas, and now what we have to do is, first we can calculate the time that it takes to reach there. Here we can write g instead of a. So v we know is 0, so u equals to gt, or t equals to u by g, which is equals to 5 by 10, 0.5 seconds or half seconds. So you can note this thing down, that whenever a body is thrown upwards, we have the standard formula of the time being u by g, always. Provided that the stone is thrown vertically upwards with a certain velocity. So this will be your formula. Okay, so the height attained, now since we have the time also, time is, I'll just write half seconds here. So yeah, so now what you're going to do is, we are going to find the s, right? So any formula we can use, ut minus half gt square, which is equal to 5 into half minus half into g into t square is 1 by 4. Then again just 5 by 2 minus 5 by 4 I can give, which is coming to your 1.25 meter. Okay. So yeah, this is all that you need to know. So height attained will be 1.25 meter. Okay. Abdul, while driving to school, computes the average speed for his trip to be 20 km per hour. On his return trip along the same route, there is less traffic and the average speed is 30 km per hour. So what is the average speed of the Abdul's full trip going and back? So you will be, on seeing this question, you will be tempted to just add the speeds and divide it by 2, but that is not how we calculate average speed, right? So we calculate average speed by total distance traveled by total time taken, right? So I hope you guys will remember this and not simply add the speeds and then subtract it and then divide by 2. Okay. So now we know the formula. So let us, since we don't know the exact distance between Abdul's school, home and school and then back, we are just going to take it as d. Okay. So from going home to school, what is the time taken by Abdul? We can give it as d by 20, right? Distance divided by speed, because we know v equals to d by t. So t equals to d by v. Okay. Okay. So d by 20 seconds. School to home में लगेगा d by 30. Okay. So since now we have both these things, we can just yeah, so from school to home it will take d by 30. Okay. So now we will calculate with this formula. So average speed, let us write it as SA, is total distance traveled. You know how much is the total distance? It is d plus d. 2d divided by d by 30 plus d by 20, right? So we cancel out the d's here. So 2 divided by, we take the LCM, which will give us 60. So I'll just write it above. So put a star mark here. Okay, so 2 divided by 60 हो गया, and 2 plus 3. So 2 into 60 by 5. So what is the average speed for Abdul's trip? It is 24 kilometer per hour. I hope this is clear. Okay, now we come to the graph. Figure shows the distance time graph of 3 objects. Okay, which of the 3 is traveling the fastest? So in the previous class, when I told you about the how to determine the which is going at a greater speed or which greater which is undergoing the greater displacement, greater acceleration, is one way to find out is to measure the slope. So out of these 3, which one do you think has the highest slope or the most steep, right? Because more steep the line is, more is the slope. So that will obviously travel the fastest, because you know that slope in a distance time graph will give you velocity. So the one with the highest slope, which means the one with the highest velocity. So in this we can see that B has the highest slope. So answer of A will be B. Are all 3 ever at the same point on the road? Can you see in the map? Can you see in the graph? Well, they are, the 3 of them never are, because they are not intersecting at the same point, the 3 of them. The 2 are intersecting individually, but not all 3 of them together. So no. How far has C traveled? How far has C traveled when B passes A? So when B passes A means at this point they are saying how far has C traveled. So at this point, if we coincide it, if we take the measurement at this point, we just use a different color. Just use black. At this point, how much has C covered? C is here, right? So we have to find the point of C, like how much it has covered. It will come to at around, see, 1 meter. Sorry, this is the time. So we have to calculate here. It is given that it's taking like about 1 hour. So basically they are saying that after they have started from the initial point, after 1 hour, what is their relative distance. So to find the distance of C, or how much it has covered, you can understand that it has covered 8 kilometers. So how did we find this? First we saw when B passes A, what is the corresponding point of B, right? It is this one. What is the corresponding point of C, sorry. And then we saw the corresponding distance it has traveled at that particular point, and it is 8 kilometers. So this will be 8 kilometers, and it is after 1 hour from its initial journey. D. How far has B traveled by the time it passes C? Okay, so B has passed C at around about this point, right? Almost. So how far has B traveled? We take a near about this point if we take. So it is coming more or less between 4 and 8, right? So we can say approximately 6 kilometers. Okay. So this was like an interesting velocity sum. So you can just later, if you have a problem, you can just pause the video and watch it again. Okay. This is another graph. Find how far does the car travel in the first 4 seconds. Okay, so it is a speed time graph. How do we find the distance? We find it by the area covered, right? So first 4 seconds means up till this point, this part. Huh? So we just shade this much portion. We have to basically, right? So we have to do nothing. We have to just basically shade the area on the graph that represents the distance traveled by the car during this period. We don't have to find it out because it's a curved line, so area of this will be difficult to find. So we know that first 4 seconds, so this is the area. Which part of the graph represents uniform motion of the car? So what did we talk about in a few slides earlier, that in a speed time graph, what is the uniform motion? It denotes when the speed is parallel to the time axis, right? It gives us that the same speed is being maintained with passing time, which means that the body is moving in a uniform motion with steady velocity. So which part of the graph represents the uniform motion of the car? We can say roundabout from 6th second to, however, let's say 10 seconds. So from T6 to T10, we have uniform motion. Okay, so this is part A and part B is T6 to T10 or 6 seconds to 10 seconds, whatever. So these are some different manipulations of graphical representations. With this, we come to the end of this discussion, and in the next class, we will be talking about the laws of motion. So thank you.